Morning, everyone. How are you guys doing today? How's your PLTL? Good. What did you do there? Did you go over review sheet or 3.5? Great, great. So just a reminder, our exam 1 will be exactly 1 week from today, next week, Friday. Definitely don't be late. You won't be late, right? Because you have PLTL before class. So still, don't be late. I cannot give you any extra time after 12. And compared to our time, exam will be a little bit longer probably. So if you don't come early or if you don't come on time, then you may not be able to finish the exam. Okay. I didn't make the exam yet, but I'm planning to give you the exam on chapter 3 and from chapter 4, 4.123. Okay. Any question, comments, concern, complaint, anything? Nothing? Okay. So yesterday we did a function, and last thing we did was evaluating function. We substitute x with whatever number that they gave us to substitute with, and then simplify. One thing we noticed that we can simplify a fraction and unfraction if the denominator and numerator have something in common. So I can reduce them instead of multiplying using sandwich method. So if you reduce your fraction, then you actually end up getting good numbers. You don't have to work with fractions if you do that. So today we're going to start with a new type of function. It's called absolute value function. What absolute value function does is if you input anything inside the absolute value machine, that number always comes out to be a positive number. Okay. So they gave us a function f of x equals we are going to learn more about absolute value later. But for now, just remember absolute value is a function. Any number inside the absolute value becomes positive when you take out the absolute value. So, I hate that. Okay, so our function is f of x equals absolute value of 2x minus 1. And they want us to find f of -2 first. So first you're finding f of -2. It means replace all the x's with -2. So 2 times -2 and then -1. And using algebra, we simplify this. So what is 2 times -2? -4. So you have -4 minus 1. And how much is -4 minus 1? -5. Now you cannot leave your answer like this because you always have to pull out your absolute value. So when you pull out your absolute value, the negative 5 actually turns into a positive 5. Okay? Why? Because absolute value means distance. So it's asking from 0 to negative 5, how much is the distance? So we have 0 here, negative 1, negative 2, negative 3, negative 4, negative 5. From 0 to negative 5, we have 1, 2, 3, 4, 5 unit distance. So that's why this absolute value of negative 5 is positive 5. Okay. Any question? So these lines, my pen is not working. Try the other two. What is f of 1/2 and f of 7? So these two vertical lines, it means their absolute value. Absolute value. It means the distance from 0 up to that point. So your job right now is to find what is f of 1/2 and what is f of 7. Ready? Not yet. Okay, it's done. 13 for what? F of 7 or F of 1/2? 7. So we replace 7 here. We get 2 times 7, 14, minus 1, which is 13. And 13 is already a positive number, so when you pull out the absolute value, it's same as 13. Good job. Who would like to do f of 1/2? F of 1/2? 0? Okay. So we have 2 times 1/2. So what is half of 2? And we have 1 minus 1. So our answer is 0. Perfect. So if you observe, it doesn't matter what number we have inside our absolute value machine, positive, 0, or negative, they always come out to be positive numbers. With this, you're done in section 3. With this, you're done with evaluating function, and now you're going to our last concept, domain and range. And you already talked about domain and range at the beginning, right? Domain represent what? X values. and range represent y values. And we also call domain as input and range as output. So what we're going to do today is we are going to identify domain and range from graphs and also from different types of equations. So when we are talking about graph, in order to find domain, we look at the x-axis. In our function, what is the smallest x value to what is the largest x value? That's the domain. Similarly, for range, we look at the y-axis. In the graph, what is the smallest y value and what is the largest y value? We combine them, we put them together in interval notation and comma between them, it becomes our range. For example, a line. It's a line, right? Increasing or decreasing? What type of line is this? Increasing line or decreasing line? Daniel? Increasing. So we have an increasing line, and the arrow, it means they're going on forever and ever, okay? So in a line, what is the smallest x value we see? Think about a line. A line is going on forever and ever and ever. So what is the smallest x value we have in a line? Okay, what is the smallest x value we can plug in a line? Can you plug in 0? Can you plug in -1? Can you plug in -5? Can you plug in -5 million? Negative infinity. We can plug in any negative number in a line. So the smallest x value we see in a line is negative infinity. So this line going on and on forever. As a result, look at the x values. They're decreasing. All those x values, they're getting smaller and smaller and smaller. Here our x value is 4, here x value is 8, here x value is 10. All these numbers, as the line is going downward, look at the x values, they're getting smaller and smaller and smaller and smaller. So eventually at the end, we have the smallest x value, negative infinity. The line is also going on forever upward. So what is the smallest x value we'll find in a line? Positive infinity. The line is going on forever. The smallest x value we have is the positive infinity. So the domain is the negative infinity to positive infinity. It's the smallest x value to the largest x value you see in a graph. So this interval means we can plug in any number for our x in a line and we'll get a valid y value. Similarly, range. Since the line is going on forever, observe the y values. This point has y value here, -2. This point has y value here, -10. As the line going on, what is happening to the y values? They are getting smaller and smaller and smaller. So what is the smallest y value we are going to get? Negative infinity. And as the line going upward, what is happening to the y values? Positive infinity. So our range has the same interval from negative infinity to positive infinity. So what we are saying here is that we can plug in any number for our x. As a result, we'll get any number for y. We don't have any problem in a line. We don't have any break, any stop, any jump, any hold. We have no problem in the line. So you can plug in any number for x and we'll get any number for y. We can plug in positive, negative, 0, fraction, whole number, weird numbers. We can plug in anything for our x and we will get anything back for our y. Is this clear? Okay, then you try next one. Find the domain in range. Remember, domain is from the smallest x value to the largest x value, and range is from the smallest y value till the largest y value. So today is 2/7. Janisha Cadet, Eliza, Maimuna, Fabricio, Sergio, Miley, Henlart, Oliver is here, Himadri is here, Mustafa, Jacqueline, Gia in here, Allison Martinez, Anaya, Jason, Atziri, Anthony, Joseph, Sitleli, Seda, Mohammed, Ronaldo, Daniel, Riza Shahid, Jeremiah Steele, Camila, Philia, Haley, should be absent, Jasim, Jeremiah Jakif, ready guys? Who is lost? Who has no idea what's going on? Ronaldo, help me with this. So this graph, what x value you notice is the smallest x value? You can keep tracking your x values. So this point has x value here, right? Now if you observe this point, it has x value there. Now this point, it has x value here. And the line is going on forever. So what do you notice about the x value? What is happening to the x value? Are they getting bigger? Are they getting smaller on the left side? We have 4, and then we have 0, and then we have -2. So what is happening to the x values? Getting smaller. And the line is going on forever and ever and ever and ever. So what is happening to the number on the left side? They're getting smaller and smaller and smaller and smaller. So what is the smallest number we have on the left side? -infinity. So we don't know where it stops. So we have -infinity on the left side of the x-axis. Similarly, our right side is also going on forever. So as the graph is going on the right side, what is happening on the x-axis? All the numbers. Bigger and bigger and bigger and bigger. So what is the largest number we have in the x-axis? Positive infinity. Just going on forever. So what's the domain? Positive infinity. Perfect. So you can plug in any number for x in this graph. By the way, this is the absolute value function. So the absolute value function we worked it before. This is the graph of the absolute value. The absolute value, they're going on forever, both left and right. So you can plug in any number on the left, any number on the right. As a result, our domain is from smallest x value to the largest x value. Who would like to help me with range? Jeremiah. Great. The smallest y value you notice is here, and this number is 3. We have no number for y below 3. So smallest y starts from 3, and as the graph going upward, look at the y value. They're getting bigger and bigger and bigger and bigger, and the graph is growing forever on the upward side. So it starts from 0 to infinity. Sorry, 3 to infinity. Now, infinity is a symbol. We don't know what's the number for infinity, so we always put parentheses for that. But 3 is a number. Now, for 3, we have two scenarios. If you have a closed circle at 3, we have to put bracket here. It means the y value 3, it exists in the function. However, if you had a picture like this, and if it was 3, you see, at that point, we have a hole. That means y value doesn't exist for 3. So for that scenario, y, our range would have been parenthesis 3 and then parenthesis infinity. What does that mean? Parenthesis means the number is next to that parenthesis. It doesn't exist in the graph. So in this graph, 3 doesn't exist because we have a hole there. So 3 gets parentheses. You may wonder why infinity gets parentheses. Because we don't know what is infinity. Since we don't know what is infinity, so we put that as a parenthesis. We don't know what's parenthesis. So infinity always get parentheses. Whether negative infinity, positive infinity, doesn't matter, it's always parentheses. But when you have a number, we have to look at two things. Do we have a closed circle or do you have an open circle? If you have an open circle, it's parentheses. But if you don't have any circle, or if you have a closed circle clearly visible, then it's bracket. So let me write this down here. Open circle means parentheses, and a closed circle means bracket. And sometimes you may not see any circle. So if you see a line, something like this or that, it also means it's closed circle. So as long as you don't see a hole, it's always bracket. Okay? Only when you see a hole in a function, that time we put parentheses. Question? So, five is here, right? Don't you have any number after 5 or before 5 for x value? For this point, what is the x value? That means you do have a number that is bigger than 5 for x. Same thing here. For this point, it actually is -2. That means you do have a number that is smaller than 5. So every point you see, you look at the x, that gives us the domain. But every point you say, look at the y, that gives us the range. Good question. Any other question? No? Try this one. This number is 8. It's the x value 8. And I will ask this in the exam. I'll give you a few pictures, probably 3 pictures. You have to find domain and range for each one of them. And I have one last one. It's a line that goes through the x, y value 3. Find the domain and range for each. You can talk to your neighbor, you don't have to struggle alone. Have a conversation with your neighbors. Ask them, what do they think? Remember, domain is the x, range is the y. Domain also can be one number. It doesn't have to be an interval. It can be one number or it can be an interval of numbers. Ready? Okay. Mustafa. The left one. Perfect. Range is the y value, so negative infinity to positive infinity because the line is going on forever. So you see y values for each one of them. Upward, the line is going on forever. So we have so many y values. How about the domain? Eight to 0, if you say, that means we have to have a graph here. Do we have any graph here? Do you have any graph after 8? So for which x value you see the graph? 8. Only one x value, right? That means our domain consists of only one number, 8. And when you have only one number, we don't use parentheses or bracket. We use a new thing called curly brackets. if your domain on range has only one number, use curly brackets. And if it has a bunch of numbers, then we use parentheses or intervals. Sorry, parentheses or brackets, square brackets. Any question on this one, the last one? Okay, what do you think about the right one then? Go ahead, Anthony. Perfect. Our X is going on forever and ever and ever on the left side and right side. And how about the range? Just 3, wonderful. See, the only Y value we have in this graph is the Y value 3. So our range has only one number, 3, but look at the domain. For this one, we have a number here. This one has a number here. This one is a number here. So we have every number from the x-axis in our graph, but for the y, there's only one number we have from the y-axis. Okay? Any question? All right, then. We are done with graph, and now we are going to the function. By looking at the function, how do we find the domain? Now, in this class, we are going to talk about only 3 types of function. You can actually ignore this 2. We are not going to work with any odd root function. We are going to work with polynomial, even roots, and rational. Polynomial. Polynomial means anything that doesn't have a negative power, fraction power, or negative power or fraction power. So it could be y equals a line, mx plus b. It's a polynomial. You can have y equals x squared. It's a polynomial. You can have y equals x to the 100 plus x to the 7. All of these are polynomials. So polynomial means our variable has no negative or fraction power. Okay, no negative power, no fraction power, and they cannot be on the bottom. So variable cannot be on the bottom. Can't be on the denominator. So variable cannot be on the denominator. It cannot have any negative power or fraction powers. Example, a line is a polynomial, a parabola is a polynomial, anything with positive degree or positive whole number power is a polynomial. So when you have a polynomial, we can substitute our x with any number. We can put any negative number for x, any 0 for x, any positive number for x. We can substitute x with any number and we get any number back. That's why our domain is everything from negative infinity to positive infinity. And similarly, our range is also everything from negative to positive infinity. So when your function doesn't have a problem, you can substitute x with anything. So domain is everything. Now problem starts in the second one. What if you have an even root function? For example, y equals square root of x. Now, can you plug in anything for x in any even root function? Can you plug in 0 here? What is square root of 0? 0. So we can plug in 0. Can you plug in 1 here? What is square root of 1? 1. Can you plug in 100 here? What is square root of 100? 10. Can you plug in 125 here? What is square root of 125? I don't know, whatever that number is. Okay. So we can plug in any positive number and also you can plug in 0 here. Now, can you plug in x with negative number here? If I put x is -1, what is square root of -1? It doesn't exist. Why it doesn't exist? Because square root means find a number. If you multiply the same number twice, it will become the number inside. That's why square root of 25 is 5, because 5 times 5 gives us 25. So when you take the square root, it becomes 5. But if you have -1, can you think of a number when you multiply the same number twice, it will become -1? Is it possible? In order to have a product 1, either you have to have -1 twice or +1 twice. There is no way you can multiply the same thing twice and it turns into a negative. So it's not possible. Since it's not possible, so we cannot substitute x with any negative number. That means square root of or an even root of function has some problem. They cannot take everything to substitute their x with. We have to be careful. We have to see what numbers we can plug in for x. And those numbers will give us the domain. So how do we find that? Let's say you have a function y equals 3x minus 5 under the square root. So we know domain for this one is starting from 0, we can plug in everything. So 0 to infinity is domain for this function. But how do I know domain for this function? We wouldn't know directly, right? Without doing any math. So in order to find domain for any even root function, we start by the condition. In order to plug in anything inside the square root, that inside function, it has to be bigger than or equal 0. For example, here, our inside function is only the x. It has to be bigger than or equal 0. For this problem, our function is 3x minus 5. So this thing has to be positive or 0. So we set this function bigger than or equal 0 and we solve for x. Then we get our domain. Starting from that number until infinity, we can plug in anything for x in that function. So in order to find domain, step 1 is identify, do you have a problem with that function? If you do, how can you solve that problem? So even root function has a problem with negative numbers. To solve this problem, we make sure whatever we have inside, this whole thing is positive or 0. Now we have last type of function, rational. For example, y equals 1 over x. Can you plug in x with any negative number? For example, -2. 1 over -2, is it a real number or it doesn't exist? 1 over -2. Come on, guys, I'm asking a real life question. What is 1 over -2? Is it a real number or is something doesn't exist? Huh? Doesn't exist? Think about the number line. We have 0 here, 1, 2, -1, -2. Can you spot one have -1 have in the number line? Between 0 and -1. See? 1 have does exist. Can you put x with 100 here? -100. Probably outside the building, that's yours. -1 over 100 is actually somewhere here. It's smaller than -1 over 2. But it does exist. Yeah, -100 is big, but 1 over -100 is small. So true. So we can plug in x with any negative numbers, we have no problem. We still get something real. How about plugging x with any real number, any positive number? For example, 2. If you plug x equals 2, we have 1 over 2, right? 1/2. Is 1/2 a real number or doesn't exist? Real number. If you plug in x with million, 1 over million, is it a real number or something doesn't exist? Still real, right? So the positive number real, negative number real, all these number reals. So can you plug in x with anything here? Can we? You think yes, right? 0. So we notice positive exists, negative exists, but what if we say x is 0? That's time we get 1 over 0. What is 1 over 0? It doesn't exist. Why doesn't it exist? Because what we are telling you is you have $1, break your $1 into 0 pieces. Can you do that? Can you ever break your $1 into 0 pieces? Never. So rational function has one problem, the denominator cannot be 0. So how do you solve this? Well, in order to guarantee that we have a valid number to substitute with, we say whatever we have on the denominator, that function cannot be 0. That function can be a positive function, can be a negative function, but definitely cannot be 0. For example, if we have y equals 1 over 2x minus 5. Now, this whole thing definitely cannot be 0. Not only x, the whole thing cannot be 0. So we start from there. This thing cannot be 0. Then what is x? We solve for x. And that gives us the domain. We'll take anything besides that number that makes the denominator 0. Okay? So in this class, we are going to talk about only these 3 functions. Polynomial, which is no problem. Even root function, which is a problem that the inside function can be 0 or positive. And then rational, which is a problem denominator cannot be 0. So it's a denominator not to be 0, and then we solve for x. Now let's do example for each. The first one. What type of function is the first one? Is it a polynomial or not a polynomial? Remember, polynomials are anything that doesn't have variable, doesn't have any negative power or fraction power, or variable is not on the denominator. If you have this 3 scenario, it's a polynomial. So do you see any variable on the denominator for the first one? No. So one problem solved. Does your x have any negative power or fraction power? No, because x is 1 power. So is the first one a polynomial? Yes. So does it have a problem? Can you substitute x with any number? We can, because it doesn't matter what number you substitute your x with, you always get something valid for y. You can substitute x with a million. We get negative 3 million plus 5, which is a real number. You can substitute x with 0. We get 0 plus 5, which is a real number. You can substitute x with billion. So you get negative billion plus 5. It's still a real number. So it doesn't matter what you plug your x with, you always get a real number. It's a polynomial. As a result, your domain is everything from negative infinity to positive infinity. Domain means what number you can plug in for your x. And we just noticed that we plug in anything for x, So it's from negative infinity to positive infinity. Any question? Okay, how about B? What type of function is B? Look at the two scenario I gave you. Is it an even root function or rational function? Rational. And rational function has only one problem. What is that problem? Denominator. Exactly, denominator. Not only x, we care about the whole denominator. That denominator definitely cannot be 0. So not equal means definitely cannot be 0. So whatever we have on the denominator, that cannot be 0. So what do we have on the denominator? What do you see on the denominator? X plus 8. So this x plus 8 cannot be 0. Now we solve for x. We want to see which x value cannot give us 0. We subtract 8 from both sides. We are solving for x. We subtract x from both 8 from both sides. So we see that x cannot be negative 8. Because when x is negative 8, then negative 8 plus 8 becomes 0. But we don't want to have 0 in the denominator. That means from the entire number line, we can plug in any number for x. There is only one number that it cannot plug in, which is negative 8. So if you want to visualize this, we have the number line here. The smallest number in the number line is negative infinity. The largest is positive infinity. And somewhere is lying negative 8. We can plug in anything before negative 8, anything after negative 8, but it definitely cannot plug in negative 8 in our function, right? Plug in anything before negative 8, after negative 8, but definitely don't substitute x with negative 8. Now, how do we write this as an interval notation? In interval notation, we look at each interval and see what is the last number and what is the right number there. So in this interval, the smallest number is negative infinity, and the largest number we see is negative 8. So in interval notation, we write our domain as negative infinity to negative 8. Now, we definitely cannot plug in negative 8. That's why negative 8 will get a parenthesis. Remember, parenthesis means y value doesn't exist. So when you plug in negative 8, we get 0 on the bottom, y doesn't exist. So you cannot plug in negative 8 into our function, so it gets a parenthesis. And then we have a gap at negative 8, and we start again from negative 8 in the second interval. In the second interval, the smallest number we see in the graph is negative 8, and the largest number we see is infinity. So negative 8 to infinity. And again, negative 8 gets parentheses. It means we cannot plug in negative 8 in our function. That will give us something invalid. Clear? Any question? So in the exam, I'm gonna give you at least 2 or 3, at least 2 definitely. Definitely rational and root, even root, and polynomial, I'll think about it. And you have to write the interval notation. Now the last one. even root function. So we have an even root. It's even root because it's called square root. Square means even. Now for even root function, what is our problem? What we cannot have or what you're allowed to have? Can you have any negative inside the square root? No. So our problem starts from the inside. Whatever we have inside, that thing has to be bigger than 0, means positive, or it can be equal 0. So 2x plus 1 can be equal 0, or 2x plus 1 can be positive. It can be positive, it can be 0, but definitely cannot be negative. So it starts from our condition. Whatever we have inside the square root, not only x, the entire thing inside the square root, that entire thing can be 0 or can be positive. So 0 means equal 0 and positive means bigger than 0. And now we solve for x. So in order to solve for x, what do? Jeremiah, solve for x, get the x alone. But how do you know what is the smallest number we are allowed to plug in here? Can't we plug in -1? Plug in -1. What if anything's okay? What if I'm plugging negative? What if I'm plugging 1 point? Let's say 0.2. Can I plug in 0.2 here? Let's see. 2 times 0.2. Or you say anything start from 0 or 1? What did you say? What is the smallest number you can plug in? 0. Okay. Two times 0 plus 1 gives us 0 plus 1, which is 1. How about, can you plug in negative 0.2? So x is negative 0.2. Our y becomes 2 times negative 0.2 plus 1. Do you know what is 2 times negative 0.2? It's negative 0.4. Now, which one is bigger, 1 or negative 0.4? That means we can subtract 0.4 from 1 and we get something positive. See, we can plug in a negative number. So how do you know what is the smallest number we can plug in for our x? The largest number we don't know because infinity. -1, let's see. 2 times -1 plus 1, we have -2 plus 1, negative. So we definitely cannot plug in -1. It will give us -1 inside the square root. We cannot plug in -1, but we can plug in -0.2. So there are some negative numbers you can plug in, but some negative numbers you cannot plug in. So what is the smallest number you can plug in? How do you know? 0.5. How do you know it's 0.5? So 0.5 means 1/2 plus 1. Positive or negative? Which one is it? Negative. So negative 2 times -1/2 plus 1. We get -1 plus 1, 0. 0 is allowed. Yes, we can plug in -1/2. But can you plug in anything smaller than -1/2? We cannot, because if -1/2 gives us 0. Anything smaller than -1/2 will give us negative numbers. So instead of doing trial and error, what we do is this. We solve for x from the setting, and then it will give us the smallest number. Solve for x. So we have 2x plus 1 bigger than or equal 0. To get the x alone, which one you get rid of first? The 2 from the front or plus 1? We want to get the x alone. Come on, guys. We did so many solving problems. What's wrong with you today? Get the x alone. So we don't want the 2 and plus 1. Which one we get rid of first? The 2 or the plus 1? So what do you have to do? Add 1, subtract 1, subtract. So subtract 1 from both sides. We get 2x bigger than or equal -1. And now to get the x alone, what do you do? Good, divide by 2. So what do you see? X has to be bigger than or equal -1/2. It means x can be equal to -1/2. It's allowed. And also x can be anything bigger than -1/2. It's allowed. Okay? Anything smaller than -1/2 is not allowed. Because our condition says whatever we have here, it has to be bigger than 0. As a result, we found x must be bigger than or equal 1/2. So we have, let's say somewhere here is -1/2, and all the number bigger than 1/2 is 0. What we are saying here is we can take 1/2, -1/2. We're allowed to do so, and we can take everything bigger than -1/2 from the number line. So how do we write this in interval notation? What is the smallest number you see in the number line here? Good. So 1/2, the smallest thing, and we have a closed circle because we're allowed to use 1/2. So it gets a bracket, and the largest thing is infinity. And infinity always gets bracket or parentheses. Parentheses. So that's the domain for our even root function. So any even root function has one portion of the domain, either left side or right side of the number line. But rational always has more than one person. Because we can take everything except what makes the denominator 0. Any question? Who is lost? Anyone? Or everyone is lost? If you're lost, do your homework. Homework has many examples. When you do more work, you will see what is going on here. Question, Anthony, do you have question? No? So any question from anyone? Comments, concern, complaint? Okay, with this we are done with chapter 3. And now we are going to chapter 4. Let me save this. I didn't post the note yet for chapter 4. I'm going to do it after class. So chapter 4 talks about system of equations. System of linear equations, to be precise. So system of linear equations means before all this time we worked with only one line. We found the x-intercept of the line, y-intercept, slope of the line, we graph the line. So all these things are happening with only one line. And now we're not going to work with one line, we're going to work with two lines at the same time. So when you work with two lines or more than one line, you call them system of equations. And you're working with line here, so it's called system of linear equations. Solution of a system of linear equations is a number and it's a point. Solution means where the two lines are intersecting one another. Wherever they're intersecting, that's the point. and we take that point as a solution. Now, not always we are going to have a point. When you work with two lines, there are three scenarios that can be happening. Either the two lines, they are crossing one another once, so we get a point x, y as a solution. So when you get one point, we call them unique solution. Unique means one. When two lines intersect, we get a unique solution. Or the two lines we are working with, they can be parallel lines. If they are parallel lines, that means they are never going to intersect. And if they don't intersect, we're not going to get any solution. So parallel lines, they have no solution. And the third scenario, the two lines you're working with, they can be the same line, they just look different. So one line is the black one, and another line could be the green one. Two lines, they look different, but when you solve for y, you'll see they're actually the exact same lines. And when you have the exact same lines, they are touching one another infinitely many times. So we have infinitely many solutions. Not one, it's so many solutions. So our solution has three scenarios: either unique solution, no solution, or infinite solutions. Now, whatever system has a solution, we call them consistent system. If our system doesn't have a solution, we call them inconsistent system. So in the consistent system, we can have one solution or infinite solution. Okay, so if you have one solution, infinite solution, that falls under consistent system of equations. But if you have no solution, it falls under inconsistent system of equations. Now, in this class, we are going to solve system of equations, mostly solve. But in the homework, they have a different scenario also. They said, well, a order pair is given, figure out whether this order pair is a solution for this system of equations. So how do you determine that? We substitute that order pair, x and y value, into both equations. And if the both equation gives us the same result, it's a solution. If they don't give us the same result, it's not a solution. That's how you figure out. Ready? Example. We have two lines and one solution. We want to see whether the solution is actually a solution for this system of equations. Just because we have them, it doesn't mean it's a solution. It may not be a solution. So we are verifying whether this is a solution or not. In order to verify, we are going to substitute x and y into both equations. And if we have the same result, it is a solution. So first line is 3x minus 2y equals negative 13. Our second line is x plus 3y equals negative 3. When you substitute this, we get x negative 5. So 3 times negative 5 minus 2 times negative 1. That thing, is it negative 13? We want to see how much we get from 3 times negative 5 minus 2 times negative 1. And we are going to the same thing here. When x is negative 5 and y is negative 1, we want to see, does it give us negative 3? So on the left side, we have 3 times negative 5. What is 3 times negative 5? Negative 15. And we have negative 2 times negative 1 plus 2. And what is negative 15 plus 2? Negative 13. So this side does give us the same number. But how about the other equation? We have negative 5. And what is 3 times negative 1? Negative 3. And what is negative 5 minus 3? Negative 8. Do we have the same number? No. So see, one equation gives us the right result, other equation did not. So it's not a solution. In order to be a solution, both equation has to give you the left side and right side number same. So that's how we verify. So once you solve the system of equations, you can verify by yourself whether the solution is correct or not by substituting them back into both equations and see if the left side equals the right side. If not, either you did something wrong, so redo your work again. I'm going to ignore the graphing method. Let me know once you're done with this page. Then I'm going to go to the substitution method. So we can solve the system of equations 3 ways. One is by graphing the two lines and see where they intersect, or whether they're parallel, or whether they're the same line. But this method is not so good because in order to graph accurately, you need graphing paper, and we don't usually use graphing papers. This method is not so good. Instead, we are going to use a new method called substitution method. In substitution method, we solve for one variable from one equation. And whatever we get for that variable, we substitute that into another equation and then simplify. Are you guys done? Can I change my page now? Okay. Substitution method. So solve for one variable, whatever you get, replace into another variable. Example. In here, the first line is 3x minus 2y equals 7, and second line is x equals y plus 3. Well, we don't have to solve anything because they already solved one variable here. They are telling us x is y plus 3. So whatever you have for y, if you add 3 to that, that will become your x. So what you're going to do is we're going to replace this x with the information here. They are telling us x is y plus 3. So we said, well, if x is y plus 3, Then let's change the x on the first equation with y plus 3. So the first equation is 3x minus 2y equals 7. This x we are going to replace with y plus 3. And then we have minus 2y minus 7. We just bring them down. So in the first equation, we did not write x because in the second equation, they're telling us x is y plus 3 more. That's why this method is called substitution, because we substituted x with something related to y. And now you're going to just solve for y. So how do you solve for y? Distribute. So we are going to distribute. We get 3y plus 9. And we still have our 2y and we still have our 7. And then we have like terms, right? Let's combine them. How much is 3y minus 2y? Y. So we have y and then 9 and here's 7. And now we can easily solve for y. What do you have to do? Subtract 9. See, we already found our y value. What is 7 minus 9? Negative 2. So we know that the two lines, they're intersecting at 2y equals negative 2. But you also need the x. The solution must be a point. So what you do, you take this y and substitute into the second equation. The second equation is telling us that if x is whatever you have for y, add the 3 to that. So we found our y is negative 2. So we add 3 with the negative 2. How much we get? 1. And now we are happy. We have an x value, we have an y value. So we put them together as a point format to give them the answer. So the solution is 1, negative 2. That's all you have to do. If your variable is not alone, make one of the variable alone. It can be x, it can be y, it doesn't matter. Make one variable alone, and then whatever you have for that variable, substitute that into another variable, another equation. Solve for the variable, and then substitute into one of the equation to get another variable. That's it. And we can actually verify whether this answer is correct or not by substituting into both equations. So you don't have to do that, but let's check our work. Check. So 3x minus 2y equals 7, and we have x is y plus 3. We found our x is 1, y is negative 2. So 3 times 1, 2 times negative 2. Gives us 3 plus 4, 7. We have the same number. First equation satisfied. Our x is 1, y is negative 2, and we know negative 2 3 plus 3 is 1. So we have the same number. So yep, our solution is correct. Both equations verified our solution. So today is Friday. Our next class will be Tuesday. We are going to do more example on substitution, and we are going to do elimination, another process. So your exam will be on section 4.123 and chapter 3. Okay. So start doing your homework. So your homework for Monday. Let me give you homework for Monday. Homework for Monday midnight. It will be 3.5, 3.6, 4.1. Oh, 4.1 is graphing. Okay, I'm going to show you graphing later. 4.2. 3.5, 3.6, 4.2, and your quiz will be 3.5, whatever quiz you have on 3.5 and 3.6. So you have 2 quizzes, 3 homeworks to do. Monday midnight. I'm going to change the due date today. So, thank you everyone for being here. Have a good weekend, be safe, and don't forget to do your homework. Also, I posted the review sheet on Brightspace, so make sure you study your review sheet.